example 1 on the Stokes theorem. We want to verify Stokes theorem for the vector field f of x and y and z equal to negative y squared and x and z, and the surface S obtained by intersecting the plane y plus z equal to 2 and the solid cylinder x squared plus y squared less than equal to 1, basically. So whatever piece of that plane sits inside is within that cylinder, basically. So what was the theorem? Theorem was this. The contour line integral of f over the boundary, and when the direction is the direction we want, the right hand orientation, is going to be equal to the curl of f ds. So what we want to do, equal to, the equal to the surface integral of curl of f over the surface S. And so one way is we have to compute this side, that's the left hand side, and then one way we have to find the right hand side. So let's start with the left hand side. So left hand side, and we want to find the contour integral over the S of f dr. What is R? R is that oval shape that is the intersection of the x squared plus y squared equal to 1 and the plane y plus z equal to 2. So how do I parameterize that? Parameterizing the boundary, which is going to be r of t. First of all, I know that x and y have this relationship of x squared plus y squared equal to 1 in the boundary. So I just write that down. And if I do cosine of t and sine of t, then the orientation is going to be the right hand side orientation. And that's one of the things. If it goes around, it starts from x-axis, goes to y-axis, and it goes around if you're looking just at x and y. And then find z by solving in here, and that would be 2 minus y. Y is sine of t. So this is the orientation, this is the parameterization. Then find the r prime of t, and that is negative sine of t, cosine of t, and negative cosine of t. Then parameterize f, which is going to be f of r of t is going to be negative y is sine of t, so sine squared t, then cosine of t, and z is 2 minus sine of t. Then take these two and dot product them. So that would be these two multiplying negative sine to the power 3t, these two multiplying plus cosine squared t, these two multiplying negative 2 cosine of t plus sine of t, cosine of t, and then the integral basically after that. So put the in the contour integral, because the parameterization was all around, it's just going to work like 0 to 2 pi. Yeah, that was the parameterization that would give us the right orientation. And dt. Now, when you're taking this integral, there's so much to basically take the integral of. You notice that basically the integral of sine to power 3 of t is going to be 0 from 0 to 2 pi. Negative 2 cosine of t is going to be 0 from 0 to 2 pi, and sine of t and times cosine of t, which is sine of 2t, is going to be 0. So the only one that you have to compute is this one. So this is going to be equal to 0 to 2 pi cosine squared t dt, which is integral 0 to 2 pi of it's going to be cosine 2t plus 1 divided by 2 dt. Again, cosine 2t divided by 2, the integral of that from 0 to 2 pi is going to be 0. So you end up with 1 t half 0 to 2 pi, that is equal to pi. So the left hand side is equal to pi. The next part is to find the integral of the right hand side. How do I do the integral of right hand side? Again, let's go back to the problem, the right hand side. Right hand side involves curl of f and the surface integral of curl of f over s. So parametrization of the surface, so again, right hand side, parametrization of the surface is important, and then computing the surface integral of the curl. And so let's see, what is the parametrization of the surface? Surface is y plus z equal to 2, and it's within the x squared plus y squared less than 1. So how do I parameterize that? And let's go with basically x, then y is y, and z is 2 minus x. And now there's two parameters, so I have g of x and y. And then what we know is x squared plus y squared is going to be less than equal to 1. So parameterization is okay. That's the parameterization of the plane. Just there is the bounds for that parameterization is, instead of x between 0 and 1 and y between 0 and 1, is x squared plus y squared less than equal to 1. Now, to find the, basically I have to find the gx, and I have to find gy, and find the cross product of the both. And so gx is going to be 1 and 0 and negative 1. Gy is going to be, oh, I made an error in here. This is y plus z equal to 2, so this should be y, not x. And this one's going to be 0 again. And then g sub y, or partial of g respect to y, is going to be 0, 1, and negative 1. Now I'm going to compute, again, give ourselves a little bit of space, and gx cross g, partial of g respect to x times partial of g respect to y is going to be ijk 1, 0, 0, 0, 1, negative 1. And computing that, for I get 0i, for j we get 1, so j, and then for k we get 1 again, or 0, 1, 1. So that's it. I still need to find the curl of f to dot product with this. And curl of f, third time is a charm, and partial respect to x, partial respect to y, partial respect to z. And going back in here, it's negative, f is negative y squared, x and z. Negative y squared, x and z. So doing the partials, when for ith, you get 0. So 0 times 0 times I. For j, you get again 0. And then for k you get 1 minus 1 minus 2y, which is minus 2y times k. Or it's 0, 0, and 1 plus 2y. Dot product 0, 0, 1 plus 2y times g sub x cross g sub y, the partial respect to x times partial respect to y of g, and you get 0, 1, and 1. That's 1 plus 2y. Now, if you remember, the right hand side was the double integral of that dot product over the basically the boundary for parameters. And so what was the parameter? Parameters were x squared plus y squared less than or equal to 1. Now, I do not like the x squared plus y squared less than or equal to 1 in general. I like to switch to basically r and theta. So theta r, because it's the it's a disk of the actually this is a cylinder, field cylinder of the radius 1, and then so you have r dr d theta, and then replacing 1 plus 2 and r sine of theta. And then you integrate. And so how does the integration work? By first of all, multiply r through, and then what we get is r squared divided by 2 plus 2r to the third divided by 3 sine theta 0 and 1 d theta. Plugging in 0 is going to give you 0. Plugging in 1 gives you 1/2 plus 2/3 of sine theta n equals 0 to 2 pi d theta. The sine theta part is going to go away because it's going to be 0. So you would end up with 1/2 of theta 0 to 2 pi, which is again pi. So the right hand side also ends up to be pi.